Hello everyone. So today I'm going to give a topics on the subject of structural analysis 1. So in this subject, so our first topic is static determinacy and it is represented with DS. So before this topic, we need to examine on the topic of structure. A structure is nothing but so a system of connected parts use it to support a load use it to support a load. So means when an elastic member is subjected to an external load, due to this deformation takes place in the given body, and after some time the resistance is offered to the resistance is offered against this deformation. Okay, so then the elastic body is known as what? Structure. So deformation will take place obviously, but then what happened after that deformation? uh, Against this deformation, resistance will offer in this. Okay, and where there is no resistance to against the deformation, so that kind of nature is observed in the unstable structures. Means what? Mechanism. And stable structures also known as what? Mechanism. So here you can see this is a simply supported beam arrangement. So in this, along the span direction, here I'm providing internal hinge. Before this, if suppose if I'm applying external load, so this kind of deformation will develop. So there is no resistance against this deformation here, but here the deformation will not be permanent, it will be moving to its original parent position. So this kind of nature is observed in the structure. So finally I'm saying, so here resistance will takes place, here no resistance will takes place. Structures and unstable structures. And next part, structures are divided into, classified some three categories. So first one, so here skeletal kind of structures, and second one surface kind of structures, next solid kind of structures. Skeletal kind of structures, examples: roof trusses, and a system of triangular connected portions here. And next, a building framed structures without plastering walls here, only columns, beams takes place here. And surface structures is nothing but slabs in in some different kind of buildings. And next, shell kind of structures. And in shells you can see thin shells are there, and also thick shells also there. examples for shells are examples for shells are so this kind of arrangement of the slabs. Okay, in shell you can observe. So first, coming to geodesic dome kind of arrangement. You can freely flexible and design and modify the flat slab structures in any kind of shape. So here you can see thin shell structure at Sydney, and tensegrity structures. Okay, and catenary structures. So here, and membrane structures. So like here bubble kind of slabs are there. So these are very lightweight and flexible structures, so that you can see in any shape, so that you can see this kind of shells or slabs in any shape. Flexible foldable shell kind of slabs. Next, solid structures means massive foundations. Massive foundations means so you can observe at dams and bridge massive bridges, I mean to say in hydraulic structures. Hydraulic structures, you can observe this kind of solid structures. And static determinacy point of view, so you need to focus on skeletal kind of structures. So skeletal kind of structures again classified into two types. So first one, pin jointed frames. So this category is based on based on type of joint, based on type of joint, pin jointed frames, and next one, rigid jointed frames, rigid jointed frames and pin jointed frames. In pin jointed frames, so I mean, you can say only axial forces are developed, but in rigid jointed frames, bending moments and shear force and twisting moments and axial forces also developed, axial forces also developed. But in pin jointed frames, they developed only axial forces, but in rigid jointed, so bending moment, shear force, twisting moment, and also axial forces. Okay, but not in pin jointed frames. These are the examples for rigid jointed and pin jointed frames. Next, based on the dimension. Next category, this is based on type of joint, right? So next category, based on dimensions. So first one, plane frames, and second one space frames, sorry, space plane frames, space frames, means 2D and 3D kind of 3D kind of structures. So again here, pin jointed plane frames, and here rigid jointed plane frames. In this also, pin jointed space frames, and next one, space joint, sorry, rigid jointed space frames. Once again, I'm repeating here, based on type of joint, pin jointed frames and rigid jointed frames. Pin jointed frames develops only axial forces, but rigid jointed frames are developing total four. So that is bending moment, shear force, twisting moment, and also axial forces. This is rigid connection. This is pinned connection. And next category based on the dimension. So first one, plane frames. Second one, space frames. In planes, again I'm taking the pin first one, and next I'm taking rigid. Pin rigid with planes. Next pin rigid with space. Here two and here two. Pin jointed plane frames, rigid jointed plane frames. Pin jointed space frame and rigid jointed space frame. Next, in plane frames, number of equilibrium equations along h directions, along y directions, along rotation directions, all are 0. Sigma h equals to 0, sigma v equals to 0, sigma m equals to 0. Or you can write also in a way that sigma fx equals to 0, sigma fy equals to 0, and sigma mz equals to 0. So that is or. Okay, here I'm writing or. You can write sigma h, sigma v, sigma m, all are zeros. Summation of forces in all the direction are zeros, and forces along x direction 0, forces along y direction 0, moments along the z direction 0. So total equilibrium equations are 3 in this case. And but in space, number of number of equilibrium equations are 6. Okay, means sigma fx 0, sigma fy equals to 0, sigma fz 0, and I'm considering here moment in all directions also 0. That means sigma mx equals to 0, sigma my equals to 0, and sigma z also 0. That means total 6. And next in pin jointed frames, so here basic element is triangle. So pin joint means మీకు పిన్ జాయింట్ అనగానే మీకు గుర్తొచ్చేది ట్రయాంగిల్ కైండ్ ఆఫ్ అరేంజ్మెంట్స్ ఉంటాయి. ఓకే, అండ్ ఫర్ ఎగ్జాంపుల్ హియర్ ప్లేట్ కనెక్షన్స్, ఐ మీన్ స్టీల్ ప్లేట్ ఆర్ మెటాలిక్ ప్లేట్ కనెక్షన్స్ ఉంటాయి కదా, లైక్ గజెట్ ప్లేట్ కనెక్షన్స్. అండ్ ఇంకా ఒక ఎగ్జాంపుల్ ఇవ్వాలనంటే ఆర్ ఎల్బో జాయింట్. Elbow joint is okay, I mean best example for pin jointed. And here you can observe, so before and after, so deflections are different. Suppose this kind of arrangement is there, but after this, suppose after some time it is subjected to some external load, so the deflection shape, so maybe in this way. So this is original actually in this way. So before and after, the members, the angle between members is varies here. Suppose before attacking the external loads, the angle between members is suppose 30 degrees angle, but here here the between members the angle is greater than 30, greater than 30, or it may be 40 or 50 or less than 20 also may happen. But in rigid, opposite to this, so I mean before and so after deformation, after deformation, so the members, so here, so one member and here second member, the angle between these two is 90 degrees. And after deformation also, after deformation means I'm showing here, so I'm showing, so this is the deformation, this thick portion is deformation of the rigid jointed frame. So here also the angle between 90 degrees. After deformation also, the member between the member angle is remains the same. So that is the main difference between pin jointed and rigid jointed frame. And here example is our shoulder joint. Our shoulder joint. And next, focus on the structures. It may be any kind, pin jointed or rigid jointed. First, see, for example, I'm taking here rigid jointed frame. So here, see, directly visually, I'm saying, so this frame is subjected to two fixed supports. That means it should be strong. It should be strong. At end of the column members, okay, end of the column members, that means it supports, I mean the developed forces or the developed reactions at fixed supports, you okay verify, you have to verify. So the developed reactions at the supports, I mean it should be strong externally, okay. So this strongness this strongness based on the support we can say, okay. So the strongness of the external structure depends on what? Support mainly. Next one, members. In members, inside the members, so due to some natural forces or some external forces, inside elements will disturb, so that some kind of forces developed inside the members. So inside also forces developed, I mean some kind of reaction forces inside the members. So it should be strong in internally also. Okay, should be strong in internally, and it should be strong in externally also. External okay, external strongestness depends on supports, and internal strongestness depends on what? Members. What? Members. That means we are having one formula to check the stability, external stability, and also internal stability. External stability depends on supports, and internal stability depends on members and also the joints. We are having one formula, m equals to 2j minus 3. M equals to 2j minus 3. The number of members equivalent to the 2 times of joints minus equilibrium equations. Here equilibrium equations are 3 I am writing for 2D frame. Okay, or otherwise you can check r minus 3 equals to 0. I mean number of reaction forces developed in the given structure minus equilibrium equations equals to 0. Okay, suppose it is satisfying this relation. So this kind of structures under determinacy, that means we need to easily check the stability of the structure external side and also internal side with the help of, okay, satisfied equilibrium equations. So that kind of structures known as statically determinate structures. Statically determinate structures, that means a structure so which is having a external supports and also in members developing inside the forces due to these external forces. Okay, and this stability depends on what? M equals to 2j minus 3 relation, a structure which is having some external supports and also internal members. Okay, so this structure overall stability depends on what? Its external stability and also internal stability. So for this we need two relations to check. R minus 3 equals to 0. So this is about external number of reactions developed at the supports minus 3, and m equals to 2j minus 3 means internally. I mean number of members in this equals to 2 into number of joints. Here 1 joint, 2 joint, 3 joint, 4th joint minus number of equilibrium equations. So this relation is satisfied. This kind of structure is known as statically determinate structures. Okay, and suppose here members are not equivalent to this side. I mean left side is not equal to right side. For example, say 5 equals to 5 and here 4 equals to 5 and 6 equals to, here 6 is greater than 5 and 4 is less than 5 and here 5 equals to 5. So if you will be getting 5 equals to 5, then you can say it is determinate structure. If 4 is less than 5, so then you can say it is indeterminate, and also you can spell it as deficient structure or unstable structure. Deficient structure, unstable structure, improper structure, and indeterminate structure. And if 6 is greater than 5, it is extra sufficient structure. What? Extra sufficient or overstable structure, or overstable structure, and also indeterminate structure, So this is about statically determinacy. Okay, once again I'm repeating. The structure for which the reactions at the supports and internal forces in the members and can be found out by the conditions of static equilibrium equations is called statically determinate structures. Okay. And to check the external stability and internal stability, so we are having two relations. For external check r minus 3, for internal check m equals to 2j minus 3. For example, here I am giving, if you got number of members 5 and 2j minus 3 value is also 5, so it is determinacy. If number of members 4 and 2j minus 3 value 5, so that means it is indeterminate. It is indeterminate and also not sufficient structure, deficient structure, and unstable structure. And if number of members greater than 2j minus 3, so it is extra sufficient, or it's also known as over sufficient structure and indeterminate structure. Next, statically determinate. Next, statically indeterminate. Statically indeterminate. So means here sufficient equilibrium equations to resolve the forces developed inside the members and also reactions at the supports ఒక స్ట్రక్చర్ ఉంటే ఒక స్ట్రక్చర్కి ఎక్స్టర్నల్గా ఉన్న సపోర్ట్స్ దగ్గర డెవలప్ అయిన రియాక్షన్స్ని అండ్ దీనికి కనెక్ట్ అయి ఉన్న మెంబర్స్లో డెవలప్ అయిన ఫోర్సెస్ని ఈజీగా అనలైజ్ చేయడానికి, ఈజీగా ఫైండ్ అవుట్ చేయడానికి మనకి 3 ఈక్విలిబ్రియం ఈక్వేషన్స్ సఫిషియెంట్గా సరిపోతే సో దాన్ని స్టాటికల్లీ డిటర్మినేట్ స్ట్రక్చర్స్ అంటారు. స్టాటికల్లీ ఇండిటర్మినేట్ మీన్స్ మనకి ఈ 3 ఈక్విలిబ్రియం ఈక్వేషన్స్ సరిపోవు. ఓకే, సరిపోవు. We need some more equations to analyze the structures. అంటే some more equations అంటే వాటిని మనం ఏమనాలంటే కాంపాటిబిలిటీ ఈక్వేషన్స్ అంటే అలాంటి వాటిని అనలైజ్ చేయాలనంటే we need to put some more effort and some more advanced equations, advanced methods. Okay, for that kind of statically indeterminate structures. For example, statically determinate structures ki simply supported beams, in short SS beams నేను రాస్తున్నాను, simply supported, and cantilever beams కూడా example determinate structures ki, and ఓవర్హ్యాంగ్స్లో సింగిల్ ఓవర్హ్యాంగ్ అండ్ డబుల్ ఓవర్హ్యాంగ్స్ కూడా డిటర్మినేట్ స్ట్రక్చర్సే. అండ్ ఆల్సో 3 hinged arch అంటే ఆర్చ్ స్ట్రక్చర్ ఇలా ఉంటుంది. ఇక్కడ 1 hinge, ఇక్కడ అనదర్ hinge, and along the rib of this section other hinge. Suppose I am providing here 1 2 3 third hinge. Okay, so hinge is having 2 reaction forces. Okay, suppose r minus 3 equals to 0, 2 plus 2 4 minus 3 equals to 1. But ఇక్కడ extra hinge ఉంది కదా, hinge connected to number of members -1. Here hinge connected to 2 members -1 equals to 1. ఈ 1ని మనకు వచ్చిన ఆన్సర్ నుంచి డిడక్ట్ చేయాలి. 1 minus 1 0 అంటే 0 వచ్చింది కదా. సో డిటర్మినేట్ స్ట్రక్చర్ ఇట్ ఈస్. ఓకే, డిటర్మినేట్ స్ట్రక్చర్ this one. And simply supported beam also, for example, simply supported is having 1 hinge and 1 roller. Okay, so hinge is having 2 reaction forces, one vertical and one horizontal, and roller is having only vertical reactions 1, 2, 3. Okay, number of reactions are 3. Formula enti r minus 3 equals to 0. Here I am checking externally. That's why I am preferring here r minus 3 equals to 0 equation. ఇక్కడ r అంటే ఇక్కడ 1, 2, 3. 3 minus number of equilibrium equations are 3. 3 minus 3 equals to 0. సో అలా మనకి 0 వస్తే దాన్ని స్టాటికలీ డిటర్మినేట్ స్ట్రక్చర్స్ అంటారు. ఎగ్జాంపుల్ సింప్లీ సపోర్టెడ్ క్యాంటిలీవర్, సింగిల్ ఓవర్ హ్యాంగ్ బీమ్స్, డబుల్ ఓవర్ హ్యాంగ్ బీమ్స్ అండ్ 3 hinged arches. అండ్ ఇండిటర్మినేట్ బీమ్స్కి సో బెస్ట్ ఎగ్జాంపుల్ ఫిక్స్డ్ బీమ్. ఓకే, సో ఫిక్స్డ్ బీమ్ అండ్ 2 hinged arch. Okay, 2 hinged arch. Next to multi-story frames. Multi-story frames and continuous beams. More than 2 supports. Continuous beams. Student, fixed beam. For example, I am taking fixed beam is having one horizontal, one vertical and one rotation. Here also one horizontal, one vertical and one rotation. ikkada 3 unnai. 3 plus 3 6. r minus 3 equals to 0 kada. ikkada r value enta 6 minus 3 ఎంత వచ్చింది 3. అంటే ఇంకా 3 ఫోర్సెస్ని మనం ఫైండ్ అవుట్ చేయలేకపోతున్నాం. దేనివల్ల ఈక్విలిబ్రియం ఈక్వేషన్స్తోని ఓన్లీ మనము 3 మాత్రమే చేయగలం, ఇంకా 3 పెండింగ్ ఉన్నాయి. సో వాటిని చేయాలంటే వీ నీడ్ మోర్ ఈక్వేషన్స్ టు అనలైజ్. సో దిస్ కైండ్ ఆఫ్ స్ట్రక్చర్స్ ఆర్ అండర్ స్టాటికల్లీ ఇండిటర్మినేసీ. అండ్ మీకు స్ట్రక్చర్స్లో ఇంకొక టర్మ్ ఉంటుంది. సో అదేంటంటే రిడెండెన్సీ అని ఉంటుంది. Redundancy is nothing but a member is connected to extra supports or extra members. Extra forces అంటే extra supports అన్నా ఉండడం ఆర్ ఎక్స్ట్రా రియాక్షన్స్ అన్నా డెవలప్ అవ్వడం. సో అలా ఉన్న స్ట్రక్చర్స్ని మనం రిడెండెంట్ స్ట్రక్చర్స్ అంటారు. ఆ నేచర్ని రిడెండెన్సీ అంటారు, ఎక్స్ట్రా ఉండడం. ఓకే, అంటే ఇండిటర్మినేసీ టైప్ అన్నమాట రిడెండెంట్ స్ట్రక్చర్స్. అండ్ డిఫరెన్సెస్ మాట్లాడుకుంటే డిటర్మినేసీ ఇండిటర్మినేసీవి. ఇక్కడ 3 ఈక్విలిబ్రియం ఈక్వేషన్స్ సఫిషియంట్, ఇక్కడ 3 ఈక్విలిబ్రియం ఈక్వేషన్స్ నాట్ సఫిషియంట్. We need more compatibility equations to solve. Examples for this: SS beam, cantilever, single overhang, double overhang, 3 hinge. Here fixed beam, 2 hinged, multi-story and continuous beams examples under indeterminacy. And in this case, bending moment, shear force independent of the material property here. Okay, I mean here writing bending moment, shear force depends on material property. But in indeterminacy case, bending moment, shear force need not be depends on the material property. Material properties, material property means it's expansions and Poisson's ratio, etc. And here thermal stresses are not developed. But in indeterminacy thermal stresses are developed. And no stresses caused due to lack of fit. But here stresses are developed due to lack of the fit. But here No stresses are developed due to lack of fit. And it is not economical, but it is economical. So that's why people are preferring for analyzing point of view and construction point of view. So and easy way of construction point of view, people are preferring statically determinate structure than statically indeterminate structure, because it is easy to analyze and easy to construct uh, within a correct period of construction time. But here we need more skilled labor required, and we need to analyze more, so extra time is required. We need to put more effort for analyzing of structures. Next, I want to show some structure examples for determinate and indeterminate. So here SS and cantilever, range arch and column and variant trusses, and here for indeterminate fixed frame and two span continuous beam and frame with a hinge and three spans continuous beams and pin jointed frames. Thank you.